Projectile motion is one of those things that is basically unnoticed because of how common it is. Whether it's at the football game or when you drop your pencil, you're always watching it at work. So, to get a better understanding of what projectile motion is, let's do a lab. Alright, so the setup for this lab is simple. We need a table, meter stick, basketball, a computer with internet access, a baseball, and hold on, wait for it. Yeah, a ping pong ball. So this lab has a lot of stuff going on, and at school you'll definitely need a group to get this done. Sadly, all I have is just me, so helping me out today is, boom, ghost me. God, I need some friends. Okay, so once you got everything, make sure to lay it all on the table. Then sweep the balls you just placed on the table on the ground. We just need the meter stick. First, you want to place the meter stick in the center of the table, making sure that it's straight and parallel with the long side of the table. Once you're done with that, try and twist the meter stick so that it's standing upright. This will help us out later. Then get two people on the left and right sides of the table. The person on the left should have all the balls with them, and the person on the right should be ready to catch. And then your setup is basically complete. Now you just need to throw some balls. Okay, so before we get to that, quick side note. When you're recording this, you want to make sure that you get everything, and I mean everything in the frame. So you pretty much want to make sure that the person who's recording is directly in front of the meter stick, but far away enough to get the whole trajectory of the ball in the frame, as well as the whole person throwing the ball. Oh, and another thing, when you guys are throwing your balls, make sure you throw it directly above your meter stick. That'll help later on in reducing error. Basically what we want to do is throw each ball 3 times using 3 different angles. I know it's hard to be exact, but try and make around a 45-degree throw, a 67-degree throw, and a 23-degree throw for each ball. Once you have all those clips for that, we can move to the computer and work from there. Alright, so if you haven't already, go ahead and transfer the videos from your phone to the computer. You can do that by emailing it to yourself or plugging in the computer directly via USB. So I'm going ahead and dragging a video in here. I'm just going to go ahead and name it basketball. Your frame rate could be 60. It probably is, but for this video I checked it beforehand and it was 30, so I'm going to keep it as that. You don't need to touch anything else, so just hit create. Alright, so what just popped up is a pink origin. Alright, and what you want to do is you want to level it with the table, as well as when you let go of the object. So you'll see in a second, I'm trying to get it level with the table first. Just going through, trying to keep in mind about perspective, because you know this is a 3-dimensional object, so you do want to place it in a kind of correct area. So now I'm using the button in the bottom right to advance the frames forward to where I'm tossing the ball, just so I can get the point where it just barely leaves my hand, as you can see right there. Okay, so now I'm adjusting my y-axis so that it completely bisects the basketball, and you want to do this for every single clip you have. Okay, so once that's done, I'm moving this little bars on the bottom to the point that I had it on. That's just so JSTrack understands what's going on. So now I'm going to hit the second button called New Scale. And the scale is how we get our reference point, and that's what the meter stick is for. So I'm clicking one end and the other end, and this is where you type in 1 meter, okay? And so I made it a little straight because it turns out my video wasn't correctly centered. So now I'm clicking on the first button. It's called New Track, and I'm gonna name that Basketball Path. Alright, I'm gonna hit create. And so basically what you do for this is you hit shift and you click at the center of the ball, and you'll see as you do that the points on the right will start to be plotted. So shift click again, hold shift and then click the center of the ball, and you'll start making a bunch of points, and you'll start seeing the time, the X in meters, and the Y position in meters. Okay, so right now I'm just going through, just going shift click, trying to get as best as I can the center of the ball. This is a lot easier on the smaller balls, but I just want to show the baseball for you guys because that's a little bit faster to plot than some of these other ones. Alright, so as you can see what's going on, I'm kind of sort of creating a graph at this point, and we'll make a visual representation of that in a second. Okay, so it looks like we're about done. I'm just going to go ahead and move that marker, line it up with our end. So now for this graph on the end, a good way to get all this data is just to click on it. All right. And so what you want to do is hit Control A just like that. It'll highlight everything, and then you want to hit Control C to copy it, okay? Now we want to open a new tab and go to sheets.google.com. This is basically just an Excel clone, but it's more accessible, so I'm using this. So you just want to click on a new spreadsheet and paste everything in. Of course, I messed up, and what you really want to do is leave the first row blank. That way you can actually put your axis titles on it. So you can see me kind of struggling with that right now. I'm not exactly the best with it. Okay, so it looks like I figured it out. So yeah, make sure you leave your first row empty. So my first column, the title is time, and that'll be in seconds. My next column is the X position, and that is in meters. And then my last one is my Y position, also in meters. All right, so now what do we do with this data? All right, so what you want to do is highlight only the time in the X position, okay? Then you want to go over to the right where it says insert chart, right? Now you want to go your chart type, click on it, and scroll all the way down to where it says scatter, okay? Right there. All right, so click on it. And then you want to go to customize. You'll see me go into there in a second. Go to series, scroll down to where you see trend line, click on the trend line. We don't have to change anything with that. And then the label, you want to click on it and click use equation and then show R. All right, so as you can see, this kind of leaves us with a linear type of graph, and I'll leave that to you guys to interpret what that means to you. But so now we have our graph for our X values, and now it's time to compare our Y position to the time. And maybe that can give us a little bit of a deeper understanding of parabolic motion in projectile motion. So you can just see me now just fixing up my typos. I spelled position wrong. Not the best look. So now I'm probably going to be struggling with trying to get rid of this new column. So I made a completely new graph. So it looks like I'm going to delete my X column entirely. And then a good way to delete this and put it somewhere else is by highlighting it and hitting Control X. Then going to the column you want to go and hit Control V. So you're cutting and pasting. Okay. So now I'm going to label my axes again. So we have time in seconds again. And then we have our Y position in meters. All right. So now similar process as before, not exactly the same, but similar. All right. So now we want to highlight our graph, right? Go to the same button again, insert chart, and you'll see it looks a little bit different. So we want to go to chart type and still make sure it's scatter. Okay. Then we want to go to customize and go to series. Now, this is where it gets a little bit different. So we still want a trend line as usual, but we want to change it to polynomial and make sure our polynomial degree is 2. Then we want to show R, and then we also want to go to label and click on use equation. All right, so now we have two graphs here, and you'll see some similarities between the other graphs that you have. So once you get all these graphs done, for each clip that you've done, then you should be able to answer the post lab questions. So yeah, with that, I'll see you guys after the post lab. 6, 5, 4, 3, 2, 1, over.